Right now, you are moving at 1,037 miles per hour. You don't feel it. You're not holding on to anything. But you, your coffee cup, your house, the ocean outside your window, all of it is being hurled through space at jet fighter speed. That's how fast the ground beneath your feet is spinning. Now imagine that speed just stops, not slows down, stops, for 5 seconds. Everything that isn't bolted to the planet keeps moving at 1,037 miles per hour, because physics doesn't care that the Earth changed its mind. Cars, oceans, the air you're breathing. You, by the end of this video, you'll never look at just standing still the same way again. Most people think the Earth's spin is just background noise, something that gives us day and night and not much else. You wake up, the sun rises, you go about your day, the spinning part feels irrelevant. And honestly, that instinct makes sense. We don't feel dizzy, we don't feel wind in our face from spinning, so our brains quietly assume this rotation thing is decorative. Here's the crack in that idea. Everything on Earth, every ocean current, every wind pattern, every plane route, every satellite orbit, is secretly choreographed around that spin. Stop it, and you don't just lose day and night. You lose the invisible glue holding weather, tides, and geography in place. So here's what we're actually answering today. Why would stopping hurt more than the spinning itself? What actually happens to your body in that moment? And why do engineers obsess over something you'll never consciously notice? Let's go deeper than anyone has ever taken you before. Here's the physics in plain English. Everything in motion wants to stay in motion. Same direction, same speed, unless something forces it to change. Scientists call this inertia. You call it why you lurch forward when a bus slams the brakes. Right now, the spin of the Earth is carrying you sideways at over 1,000 miles per hour at the equator. Slower, the closer you get to the poles. If the ground stopped instantly, your body wouldn't stop with it. You'd keep moving at that same speed, while the ground beneath you didn't. That's not a fall, that's a launch. Here's the part most explainers skip. The air around you is also spinning with the planet. If the ground stops but the atmosphere keeps moving, you get wind, except wind is the wrong word. Category 5 hurricanes top out around 157 miles per hour. The air suddenly sliding over a frozen surface would be moving at speeds up to 10 times that near the equator. Every structure not engineered for a direct missile strike would be sandblasted, then leveled. Did you know the entire volume of Earth's oceans is essentially one giant object being spun with the planet? Stop the spin, and that water keeps its momentum, sloshing toward the equator and slamming into coastlines as tsunami-scale walls of water, thousands of miles wide. Not from an earthquake, from 5 seconds of missing motion. But here's the part that nobody talks about. This isn't even the most violent moment. The most violent moment is what happens the instant after. In textbooks, this scenario gets treated like a fun thought experiment. A what if, with a tidy, cinematic answer. Cities flattened, oceans surge, credits roll. What engineers actually think about is scarier and quieter. The crust itself. The Earth isn't a single rigid ball. It's a spinning shell of rock floating on a molten layer underneath. And that spin is part of why the planet holds an equatorial bulge, roughly 13 miles wider around the middle than pole to pole. Stop the spin, and that bulge has no reason to exist anymore. Gravity would start pulling the crust back toward a perfect sphere, meaning entire tectonic plates would face internal stress they were never built to handle. This is where the real-world comparison gets uncomfortable. Structural engineers already study sudden load stops. It's the same principle behind why the Tacoma Narrows Bridge tore itself apart in 1940. That bridge didn't fail because the wind was too strong. It failed because the wind matched the bridge's natural rhythm and amplified it into a wave the structure couldn't absorb. A sudden stop in Earth's rotation is that same principle, played out at planetary scale, with no bridge cables to snap and no engineers to warn us first. Wait, it gets even more interesting. The mind-blow moment. Even if you personally survived the wind, the water, and the ground shifting beneath you, the planet's magnetic field is also generated by that spin, deep in the molten outer core. A long enough disruption doesn't just threaten your city, it threatens the shield protecting all of us from solar radiation. Here's why this isn't just a fun hypothetical. You've probably noticed that flights from the US to Europe are shorter than flights from Europe back to the US. That's not a coincidence. Pilots are quietly riding Earth's rotation and the jet streams it creates. Every long-haul flight path, every GPS satellite calculation, every weather forecast model is built on the assumption that the spin is constant and predictable. Next time you check the weather app before deciding on a jacket, remember that forecast exists because meteorologists can trust the Coriolis effect. The sideways curve rotation gives to moving air and water to behave the same way every single day. It's why hurricanes spin counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. It's why your bathtub drain doesn't actually swirl one specific way because of hemisphere. That one's a myth, but ocean-scale currents absolutely do. And this same principle is why a spinning top stays upright while a stationary one tips over instantly. Rotation isn't just movement, it's stability. Engineers use that exact idea in gyroscopes, the tiny spinning sensors inside your phone that know which way is up when you tilt the screen. And this is just the beginning of how deep this goes. Now here's something that most people never connect to this topic. Earth's spin isn't actually constant. It's slowing down, just incredibly slowly, about 1.7 milliseconds longer per century, mostly because of tidal friction from the moon. Think of it like a figure skater doing a slow, graceful spin instead of a fast one. Over hundreds of millions of years, that skater's twirl has been gradually loosening. Days on Earth used to be shorter. A day was closer to 23 hours a billion years ago. So in a strange way, Earth has been almost stopping in extreme slow motion for its entire existence. We're just too short-lived to notice, which means the 5-second freeze isn't some alien scenario. It's the same physics playing out at a speed our senses were never built to detect. So let's lock this in. Everything not attached to the ground keeps moving at over 1,000 miles per hour. The atmosphere and oceans turn into planet-scale weapons in seconds, and the crust itself would start reshaping under stress it was never designed for. Here's the big takeaway. The Earth's spin isn't background noise. It's the invisible engineering holding your entire world together. Now I want to know, did you ever realize how much was quietly resting on something you can't now to even feel? Drop it in the comments. In our next video, we're going somewhere even most engineers haven't thought about. What would actually happen if gravity flickered for just 1 second? Because at Logivra, we don't just explain the world, we show you the logic you were never told was there.